All right, let's continue our discussion with irrational numbers. So we've already covered multiplication and division of irrational numbers, of square roots pretty much. So this time we'll be working on subtracting and adding square roots. So the nice thing about this is that when we do our square roots with the same radicand, meaning whatever is the square root and that number inside, all we need to do is work with their coefficients. Okay, so pretty much it's like combine like terms. If they have the same radicand, so square root of c, you can add a and b together. Or you can also subtract them. Okay, so remember, if you have similar radicands, similar square root parts, then you can add or subtract them just simply by using their coefficients. So in this case, add or subtract. So we have square root of 2, and we need to add them. So pretty much it's like 7x plus 5x. Okay? Remember, combine like terms. So this is going to be 7 plus 5, which is 12. Square root of 2, you are adding, okay? So it is still square root of 2, okay? Just remember, this is pretty much like 7x plus 5x. So this is going to be 12, and you just use the same variable, which is x. You do not multiply them. It's not x squared, all right? So addition and subtraction, similar radicands. So here we have square root of 5, square root of 5. So we can do our subtraction. 2 minus 6, okay? 2 minus 6 is going to be negative 4, and then our radicand is going to be the square root of 5. In this case, we have 3 of them. We have square root of 7, square root of 7, square root of 7. So what will be our coefficient? So this is going to be 3 plus 9 minus, what is the coefficient here? If you do not see a coefficient, by default, that is a 1. So minus 1. That is the coefficient, square root of 7. So in this case, you will have 12 minus 1. So this is simply square root of, 11 times the square root of 7. Now, just a quick reminder about this one. You have to be very careful when you are adding, or when you are going to dismiss radicands that are different, okay? Sometimes, even though they are different, you can still add them. Why? Because they can be, one of the radicands could be simplified, all right? So for example, I'm just going to throw this out as an example, okay? So let's say we have 3 times the square root of 2. Oh, sorry, not bad. Times the square root of, sorry, my bad. Not 4. 3 times, let me erase that. Okay, 8, it should be 8. What purple? Okay, 3 times the square root of 8 plus, let's have 5 square root of 2. Okay, let's have this, okay? If we're going to follow the rule, can we add them? No, because they are not like terms. It's a square root of 8 and it's a square root of 2. But if you will notice, square root of 8 is not simplified, okay? Square root of 8, so let's have it here at the bottom, okay? Square root of 8 can actually be factored out as square root of 4 times the square root of 2. Which means square root of 8 could be written as 2 times the square root of 2. All right? So if we have 3 and we rewrite square root of 8 as 2 times the square root of 2, okay, 3 square root of 8 will actually become 6 square root of 2. Okay? And if we add the 5 square root of 2, now we have similar terms, we have similar radicands, and so we can have this as 11 square root of 2, okay? So just because the radicands are different, you do not, you do not ignore them immediately. You got to check if maybe one of the radicands could be simplified and it could be expressed as a factor of another radicand, all right? Now, earlier when we did division, we were able to combine the radicands easily because we can do the division right away, okay? Like if you remember, we had 75 over 3. 75 over 3 could be divided. So that's why we came up with, how do you call this, with square root of 25. But what if one of the divide, what if your divisor cannot divide your numerator in this case? So this is what we call as rationalizing denominators. We are rationalizing because we do not accept, no radicals are allowed in the denominator. Okay? Your denominator should always be a whole number. Okay? No radicals in the denominator. In this case, it's possible to divide them, so there was no radical left in the denominator. So how do we rationalize our denominator? The rule is simply multiply both the numerator and denominator by that denominator. So if I multiply this by square root of 6 over 6, did I change the value of this? No, because square root of 6 over 6 is just 1. So this number times 1, it's still this number, okay? Now, why do we need to multiply this? Now remember, we should not have a radical in the denominator, okay? If you multiply square root of 6 times square root of 6, that's going to be square root of 36, which eventually could be simplified as simply 6. So, are we good now? Do we still have a radical in our denominator? No more, okay? So that's basically the reason behind that. What we need is to make our denominator a perfect square so that when we get the square root of it, we can get a principal square root, which is going to be a whole number, all right? So what now will be in our numerator? Well, from the rules of fraction, simply multiply numerators, multiply denominators. So this is going to be the square root of 15 times the square root of 6. Sorry, 15 times the square root of 6. So rewriting 15 squared of 6. Now, are we done? Remember, this is in fraction form. And so if we have fraction form, we always check, is there a common factor between our numerator and denominator? Our numerator and denominator to consider factors of, or GCF, would be the coefficient. Does 15 have anything common with 6? Both of them could be divided by 3, okay? So if you divide 15 by 3, it will become 5. If you divide 6 by 3, this will now become 2. So the final answer will be 5 square root of 6 over 2. That is how you can work it out, okay? So in this case, this is the example that I was telling you earlier. Here, we can divide it easily. But in this case, 3 over 5, can we divide that? No, okay? So we will have just split them into two different radicals. What will be our multiplier? Again, we want to make our denominator a perfect square. So this is going to be multiplied by the square root of 5, okay? So now, the denominator is going to be the square root of 25, which is just going to be 5, okay? Our numerator is now the square root of 15. Do we have any perfect square factors for 15? Nothing. So our answer is the square root of 15 over 5. Miss, why can we get the GCF? No. 15 is inside the square root. So you cannot get a common factor between 15 and 5. All right? Now, letter C is a special case. Why? Because remember, our goal in rationalizing the denominator is to make the denominator a perfect square. Okay? A perfect square. In the case of letter C, our square root at the bottom is 8. Yes, we can multiply it and make it, we can have square root of 8 times square root of 8. But is that the smallest possible perfect square that we can get with 8? If you think of it, of our perfect squares, okay, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. You can make 8 to be a perfect square, which is 64. But also, one of these perfect squares could be divided by 8. And which perfect square is it? 16, okay? So, in the rationalizing of denominator, this time we choose the smallest perfect square. So how can we make square root of 8 become square root of 16? Okay? To make it become square root of 16, we need to multiply it by the square root of 2. All right? So square root of 2. So that is why square root of 16 will now simply be 4. On the top, we have 12 square root of 2. And so, can we simplify 12 square root of 2 divided by 4? Yes, we can. 12 and 4 could be divided. So this is 1. This is going to be 3. So the final answer would be 3 times the square root of 2. And that is the simplified form. Thank you.